When the James Webb Space Telescope turned its golden mirrors toward the enigmatic wanderer known as Oumuamua, the cosmos seemed to hold its breath. This was no ordinary moment. First detected in 2017, slicing through our solar system at a velocity that screamed of origins beyond our sun's grasp, Oumuamua had already rewritten the rules of astronomy. It was the first confirmed interstellar object to grace our cosmic neighborhood, a silent traveler from a distant star carrying secrets older than Earth itself. For years, its fleeting passage left scientists grasping at shadows, blurry data, speculative models, and tantalizing hints of something extraordinary. But now positioned a million miles from Earth at the serene Lagrange Point 2, the James Webb Space Telescope has unveiled humanity's first true glimpse of this celestial enigma. What it revealed is not just an image, but a portal into the unknown, a challenge to everything we thought we understood about the universe. The image is a masterpiece of cosmic clarity, a high-resolution portrait that transcends the grainy approximations of earlier observations. Oumuamua is not a mere speck of light against the void, but a complex, almost otherworldly structure. Its form defies the simplicity of comets or asteroids. Instead of a tumbling, cigar-shaped rock, the object appears as a faceted prism. Its surface is jagged and angular, like a shard of crystal, forged in the crucible of a dying star. The infrared gaze of Webb reveals a surface that shimmers with an eerie iridescence, patches of metallic sheen interspersed with carbon-rich voids that swallow light whole. These are not the features of a typical celestial body. The object's geometry suggests something sculpted, not by gravity alone, but by forces we cannot yet name. Its coloration, a dance of reflective and absorptive zones, hints at a composition that straddles the line between natural and inexplicable. What makes this image a seismic event in science is the spectral data encoded within it. Webb's instruments have peeled back the layers of Oumuamua's surface, revealing a chemical tapestry that defies logic. Traces of solid hydrogen, a substance requiring temperatures colder than the darkest voids of space, mingle with exotic ices laced with nitrogen and oxygen in configurations unknown to our catalogues. These compounds should not coexist, not in the ratios observed, not on an object this size. The data suggests Oumuamua may have formed in an environment alien to our understanding, perhaps near a rogue planet, adrift in the interstellar medium, or within the frozen envelope of a protostellar disk, orbiting a failed star. The implications are staggering. This is not just a rock, it is a relic, a fragment of a cosmic process so ancient and distant it challenges the boundaries of our imagination. The motion of Oumuamua, as revealed by Webb's precise measurements, adds another layer of mystery. Far from the chaotic tumble once assumed, the object spins with a deliberate grace, completing a full rotation every 8.3 hours along a stable axis. This is no loose agglomeration of debris held together by gravity's weak embrace. Such motion demands internal cohesion, a structure bound by chemical or even metallic strength. The image allows scientists to map the object's thermal inertia, its ability to absorb and release heat, and the results are confounding. Oumuamua retains warmth far longer than expected, suggesting a porous matrix or, more provocatively, a hollow core. A porous body should crumble under the relentless assault of cosmic radiation and micrometeoroid impacts during its interstellar voyage. A hollow core, meanwhile, whispers of possibilities that science hesitates to voice. Could this be the remnant of something engineered? The philosophical weight of this image is as profound as its scientific impact. Oumuamua is not just an object, it is a messenger from the deep past, a time capsule carrying the chemistry and physics of a star system we may never see. Its very existence confirms that the Milky Way is not a collection of isolated islands, but a dynamic web, where material is exchanged across gulfs of time and space. The image shatters the notion of planetary systems as closed ecosystems. If Oumuamua could travel unimpeded for millions, perhaps billions of years, then countless others must have done the same, slipping through our solar system unnoticed. Webb's capture proves we now have the tools to detect and dissect these visitors, opening a new era of interstellar exploration. The question of panspermia, the idea that life's building blocks could hitchhike across the cosmos, looms large. Oumuamua's surface, rich with complex organic molecules, suggests it could carry the seeds of life, preserved through eons of exposure to cosmic rays and vacuum. The image also challenges our taxonomies. Oumuamua fits no known category, neither comet, nor asteroid, nor dwarf planet. Its prismatic form and chemical anomalies demand a new classification, perhaps an entirely new branch of celestial phenomena. This is not merely a scientific curiosity. It is a call to redefine how we understand the architecture of the universe. The object's surface, with its sharp delineations between reflective and absorptive zones, suggests a process of differentiation, typically seen in far larger bodies. Could Oumuamua be a fragment of a shattered world, a piece of a planet that once orbited a distant star? The idea that we are gazing upon the ruins of an alien geology sends shivers through the scientific community and beyond. As researchers pore over the data, the image's clarity reveals subtler truths. Oumuamua's surface bears the scars of its journey: micrometeoroid pits, grooves etched by particle winds, and a thin veneer of exotic ice that speaks of encounters with high-energy stellar environments. Yet curiously, it lacks the dust accumulation expected of an object adrift for millennia. This cleanliness suggests a mechanism, perhaps sublimation of volatile materials or an electromagnetic repulsion, that keeps its surface pristine. Such phenomena are unheard of in objects of this scale, hinting at physics we have yet to grasp. The object's low mass-to-surface area ratio, recalculated with Webb's precision, further deepens the enigma. It is impossibly light for its structural integrity, almost as if it were a thin, cohesive sheet rather than a solid mass. This raises the tantalizing possibility that Oumuamua could be a natural solar sail, its trajectory subtly shaped by the pressure of starlight. The thermal gradients across Oumuamua's surface add yet another twist. Some regions remain warmer, far longer than others, defying uniform heat dissipation. This could point to a layered substrate where exotic ices are trapped beneath a dense mineral crust formed under conditions alien to our solar system. Such stratification suggests a history of complex chemical evolution, perhaps within the accretion disk of a massive star or near a neutron star's crushing gravity. The image's spectral data reveals an isolated absorption spike in the near-infrared, a signal unmatched by any known molecule or mineral. This anomaly could be the first evidence of a new material class, one forged in environments we cannot yet simulate. Laboratories across the globe are racing to recreate this signature, bombarding synthetic materials with radiation in cryogenic chambers, hoping to unlock the secrets of Oumuamua's composition. The image's implications ripple beyond astronomy into the realm of quantum mechanics and cosmic theory. The object's crystalline facets, refracting light in anisotropic patterns, suggest a structure aligned under extreme pressure or magnetic fields. Could Oumuamua have formed near a black hole, where space-time itself warps matter into unnatural configurations? The possibility, though speculative, is grounded in the image's data, which shows a surface that behaves less like rock and more like a quantum lattice, vibrating in ways that defy classical physics. This opens the door to theories of exotic matter, perhaps even phases of hydrogen, stabilized by pressures unimaginable in our solar system. Such ideas, once confined to theoretical physics, now have a tangible anchor in Oumuamua's form. The cultural and philosophical impact of this image is seismic. For millennia, humanity has stared at the stars, wondering if we are alone. Oumuamua, in its silent majesty, answers with a question. What else is out there, drifting through the void, carrying the stories of other worlds? The image is not just a scientific triumph, but a cultural artifact, a symbol of our growing ability to touch the untouchable. Artists and poets have seized upon its angular beauty, its iridescent glow, as a metaphor for the unknown. In classrooms, it has become a beacon, igniting curiosity about interstellar distances, orbital mechanics, and the nature of discovery. The image bridges science and storytelling, inviting us to contemplate our place in a universe that is not static, but alive with motion, mystery, and possibility. As scientists delve deeper, the image continues to yield revelations. Advanced algorithms extract new details from the spectral data, mapping Oumuamua's surface topography as a chronicle of its journey. Subtle depressions suggest prolonged exposure to particle winds near a stellar corona, while parallel ridges hint at tidal forces from a long-ago encounter with a massive exoplanet. These features allow researchers to trace the object's path backward toward a potential origin in a distant star system. The absence of outgassing or a cometary tail rules out traditional explanations, leaving the door open to bolder theories. Could Oumuamua's stable rotation and clean surface suggest an active process, perhaps a faint electromagnetic field generated by internal stresses? Such ideas, once dismissed, now gain traction in the face of Webb's undeniable evidence. The image also sparks practical ambitions. Space agencies are drafting missions to intercept future interstellar visitors, envisioning high-speed probes equipped with spectrometers and cameras powered by solar sails or nuclear propulsion. These craft could rendezvous with an Oumuamua-like object, collecting real-time data on its composition and structure. Meanwhile, astronomers are proposing deep surveys with Webb to scan the direction of Oumuamua's origin, searching for faint infrared signatures of other rogue bodies. If one object could reach us, others must follow. A family of cosmic wanderers, remnants of ancient collisions or failed stars, drifting through the galaxy's currents. The image has transformed Oumuamua from a fleeting anomaly into a catalyst for a new field: interstellar archaeology, the study of objects that carry the history of alien systems. Astrobiologists are particularly captivated by Oumuamua's potential as a vessel for life's precursors. Its surface, rich with organic compounds, suggests it could have seeded planets with the building blocks of biology during its journey. Simulations are underway to test whether amino acids or nuclear bases could survive the harsh radiation of interstellar space, shielded within Oumuamua's layered structure. The idea of lithopanspermia, life's ingredients spreading across the galaxy, has moved from speculation to a testable hypothesis. If Oumuamua could carry such molecules intact, it might have deposited them on a primordial Earth, Mars, or Europa, sparking the chemistry that led to life. The image thus becomes a window into the origins of existence itself. The object's resistance to solar radiation pressure, revealed by Webb's precise measurements, further fuels speculation. Its low density and angular integrity suggest a structure optimized for stability, almost as if designed to withstand the forces of interstellar travel. Material scientists are exploring whether Oumuamua's composition could inspire new technologies such as lightweight, radiation-resistant materials for spacecraft. The object's interaction with starlight, subtly altering its trajectory, offers a natural model for passive propulsion, reinvigorating research into solar sails. If nature could craft such a structure, what might humanity achieve by mimicking it? The image is not just a snapshot, but a blueprint for the future. As the scientific community grapples with these discoveries, the image's philosophical resonance grows. Oumuamua is a relic of deep time, older than humanity, perhaps older than Earth's oceans. Its passage through our solar system, captured in exquisite detail, is a reminder of the universe's vastness and our fleeting place within it. The object carries no signal, no message, yet its silence speaks volumes. It is a survivor, sculpted by forces we are only beginning to comprehend, a testament to the galaxy's restless creativity. The image, frozen in Webb's mirrors, is not an endpoint, but a beginning, a call to look farther, think deeper, and dream of the day when we might follow such wanderers to their origins. The data continues to unfold, each layer revealing new questions. Spectroscopists puzzle over the mysterious absorption spike, theorizing it could stem from a lattice vibration in an unknown crystal or a complex organic molecule forged in a distant stellar nursery. Planetary scientists model Oumuamua's surface as a miniature geological record, its ridges and pits a map of cosmic encounters. Astrophysicists recalibrate theories of ejection mechanics, exploring how tidal forces or stellar collisions could hurl such objects into the void. Even simulation theorists, on the fringes of science, wonder if Oumuamua's geometry hints at a constructed reality, a glitch in the cosmic code. These ideas, though speculative, are grounded in the image's undeniable strangeness, its refusal to conform to known patterns. The image's legacy is only beginning. It has redefined the boundaries of observation, proving that we can study interstellar matter with the same precision we apply to planets and moons. It demands new models, new missions, and new ways of thinking about the galaxy. Oumuamua may have faded into the blackness, beyond the reach of even Webb's mighty gaze, but its portrait endures, a beacon of wonder, a challenge to our assumptions, and a promise of discoveries yet to come. This is not just a photograph. It is a revelation, a glimpse into a universe that is stranger, more interconnected, and more alive than we ever dared to imagine. As we stand on the cusp of this new era, the James Webb Space Telescope has given us more than an image. It has given us a reason to believe that the cosmos, in all its mystery, is within our reach,